We are continuing section 3.8 of our precalculus class in our notes for inverse functions. And what we have done so far is describe how the inverse functions for cosine, sine, and tangent are created with domain restrictions and how to use them. And here is a review of what we have discussed so far. You have to remember that y equals inverse sine of x means that y is some angle from negative pi over 2 to pi over 2 that has sine equal to x. Y equals the inverse cosine of x means that y is some angle from 0 to pi that has cosine equal to x. And y equals the inverse tangent of x means that y is some angle between negative 90 degrees and positive 90 degrees, and it has tangent equal to x. We all know that regular trigonometric functions are periodic functions, and there are infinitely many angles that have the same trigonometric function with some other angle, including the angles that are in the range of values that these three inverse trigonometric functions return. So we just have to keep in mind what the range of each of these trigonometric functions is, so that when we answer questions, we answer the correct angle that has this particular trigonometric function as a value. Now, let's solve some problems that are actually very popular for test questions because they require that you are familiar with both trigonometric functions and their inverses, and also you are able to visualize that on the plane. So this question, the first one, what is the sine of the inverse cosine of 1/4, is asking us for the sine of some angle theta. The angle theta is the inverse cosine of 1/4. And an angle is the inverse cosine of x if it is an angle from 0 to pi, and it has that particular cosine. So for this theta, you know that theta has a cosine equal to 1/4, and you also know that theta is in quadrant 1. How do I know that? The inverse cosine returns angles from 0 to 180. And the cosine from 0 to 90 is positive, and from 90 to 180 will be negative. So since the cosine here is 1/4, theta is in quadrant 1. They are asking you to find the sine of theta. If you watch videos in the course, you will see that they use trigonometric identities, but it is much faster if you actually just sketch your angle, pick a terminal point pick a point on the terminal side of the angle, sketch the right triangle that attaches to the x-axis, and express cosine theta as x over r. So x is 1 and r is 4. Therefore, the y here will be plus or minus the square root of 4 squared minus 1 squared. In quadrant 1, it's positive, so the y will be the square root of 15. And the sine of theta is y divided by r, which is square root of 15 divided by 4, and I answered my question. Here they are asking me to find the cosine of another angle. Let's call it phi. What do I know about phi? I know that phi is the arctan of 4/3, which means the tangent of phi equals to 4/3. And also, since the inverse tangent returns angles that are from negative 90 to positive 90, since the tangent is positive, phi is in quadrant 1. And again, instead of using trigonometric identities, I'm going to just sketch the angle. So I'm going to sketch an angle in quadrant 1, pick a point on the terminal side, sketch the right triangle that attaches to the x-axis, and express the tangent as y over x. So the y is positive 4 and the x is positive 3. And therefore, the r will be the square root of 4 squared plus 3 squared, which is 5. So now they are asking me for the cosine of phi, and the cosine of phi is x over r, which is 3 over 5. Now, since this is a rational number, actually, if I were to use my calculator, it should come out as a reasonable answer. So if I had done cosine of the inverse tangent of 4 divided by 3, I would find it to be 0.6, and 0.6 is the decimal representation of 3/5. How would I work if I wanted to check my answer here using my calculator? If I do the sine of the inverse cosine of 1/4, I will see a number that is irrational, and I don't know if it is equal to the square root of 15 over 4. However, if I check how much is my answer, square root of 15 divided by 4, if I have done a good job, it should be identical to the answer that the calculator gave for the trigonometric expression. So let's do this. This is a little different because we have two angles. We have an angle alpha and an angle beta. And they are asking us to find the sine of alpha plus beta. And in the next unit, we will have some formulas here, but in this unit, we don't know this yet. So what we do want is to figure out if we can find how much is alpha plus beta as an angle theta. Can we find the value of that? So the first one, alpha, is the inverse sine of 1/2. It means that alpha is in quadrant 1. And it has sine of alpha equal to 1/2. So how much is alpha? If I go in my formula packet, what angle in quadrant 1 has a sine of 1/2? That angle will be pi over 6, or 30 degrees. So alpha is 30 degrees or pi over 6. The next question is, what is angle beta? Well, beta is the inverse tangent of negative square root of 3. And that means that it is in quadrant 4. And it has a tangent equal to negative square root of 3. So I need to go in my packet again and figure out which sine theta divided by cosine theta will give me negative square root of 3 divided by 1, or square root of 3 divided by negative 1. And that will be this angle over here. Will give me negative square root of 3 divided by 1. This angle is not 300 degrees because it's the inverse tangent angle. So it will be negative 60 degrees. So beta is negative 60 degrees or negative pi over 3. So when you add alpha plus beta, theta will be 30 plus negative 60. That will be negative 30 degrees. So theta is negative 30 degrees. And this question is, what is the sine? So this is negative 30 degrees. The question they are asking me to answer is, what is the sine of negative 30 degrees? And I can go on my formula packet on the trigonometric circle and find negative 30 degrees and then answer what is the sine. And the sine should be negative 1/2. And again, in my calculator, I should be able to find that because the answer looks reasonable. It's a rational number. So let's try it. What's the sine of the inverse sine of 1/2, close the parenthesis, plus the inverse tangent of negative square root of 3. Close the square root, close the inverse tangent, and close the sine. And the answer should be negative 0.5, which is negative 1/2. So let's do again this. Give the exact value of each expression. You know how to check with your calculator. I will not repeat this for this example. A problem like the one on the right that returns irrational values is probably a very good test problem or exam problem. The one on the left will return rational values, and rational values are very easy to obtain with a calculator instead of by hand. The problem on the test will ask you to sketch the angle in the correct quadrant and clearly label x, y, and r with their values. You have to understand that the inverse function is an angle. Let's call it theta. You are being asked to find the tangent of theta and sketch theta. What do you know about theta? You know that the sine of theta is equal to negative 12 over 13, and theta is an angle that is an answer from the inverse sine function, which returns only in quadrants 1 or quadrant 4. Since the sine is negative, this is in quadrant 4. So I'm going to sketch an angle in quadrant 4, pick a point on the terminal side, sketch the right triangle that attaches to the x-axis, and express the sine of theta as y over r to get me the values of y and r. Y is negative 12 and r is 13. I can find x using the Pythagorean theorem. So x squared will be 13 squared minus 12 squared, and that makes x squared equal to 25. That means that x is plus or minus the square root of 25. But in quadrant 4, it is positive. So x is equal to 5. Now that I'm looking for the tangent of theta is y divided by x, and that will be negative 12 over 5. So hopefully that's an easy one to verify using the calculator, because negative 12 over 5 is a rational number. So here is another example. They are asking me to find the sine of theta. Theta is the inverse trigonometric function. What do I know for theta? I know that the tangent of theta is equal to negative 7, which is negative. That means that theta is in quadrant 4. Tangent, inverse tangent returns in quadrants 1 and 4. If your tangent is negative, you are in quadrant 4. Remember that the tangent is y over r over x. So if I sketch the angle theta in quadrant 4, pick a point on its terminal side and draw the triangle that is attached to the x-axis, the x is positive and the y is negative. Now, negative 7 equals to negative 7 over 1. So the y will be the negative 7 and the x will be the 1. I can use Pythagorean theorem to find the r. R squared will be negative 7 squared, which is the same with 7 squared, plus 1 squared, which is 50. R is always positive because it's a distance. So r is the square root of 50, which is 25 times 2, or 5 square root of 2. So this r is 5 square root of 2. They are asking me for the sine of theta. The sine is y over r. So negative 7 over 5 square root of 2. And if I need to rationalize denominators, I will multiply by the irrational part of square root of 2. So negative 7 square root of 2 divided by 5 times 2 is 10. That will be my answer. I can use my calculator to check that the answer of the trigonometric expression in the calculator has a decimal approximation that is identical to the quantity negative square root of 2 over 10 in my calculator. Another application is a 10-foot ladder is leading up against the wall. The foot of the ladder is 3 feet from the base of the wall. How far up will the ladder reach, and what is the angle it will make with the ground? So 10-foot ladder is the hypotenuse of a triangle. The building is the vertical leg. It is 3 feet out on the ground, and they're asking me for h, and they're asking me for theta. Now h I can find from the Pythagorean theorem. H squared will be 10 squared minus 3 squared. So h will be 100 minus 9, which is 91, h squared. And since we are talking about distances, I don't need plus or minus. I'm looking for positive quantities. So that will be the square root of 91 feet, which is equal to approximately 9.5 feet. Now, what is theta? For theta, I know the 3 feet, which is the adjacent, and I know the 10 feet, which is the hypotenuse. So from my formula packet, adjacent and hypotenuse are the cosine. So I'm going to use the inverse cosine to find theta. So I have that the cosine of theta is 3 divided by 10, and therefore theta will be the inverse cosine of 3/10. Again, I am in quadrant 1, so acute angles that are positive, and the inverse cosine will return that value. Now, this is the exact answer in radians, inverse cosine of 0.3, but if they need a decimal approximation to the nearest tenth of the degree, I will say what's the inverse cosine of 0.3, which is 3/10, and the answer will be 72.5 degrees, approximately 72.5 degrees. Last one for this video, the optimal angle a shot putter could aim for to throw the greatest distance depends on the velocity v in feet per second and the initial height h in feet of the shot according to the formula below. If the shot putter can throw a shot put with initial height h equals 6.6 feet, and velocity v equals 42 feet per second, what is the optimal angle to multiply to maximize the distance? So they are giving me v and h, they are giving me the formula. All I have to do is plug in the values. So in my calculator, I'm going to do inverse sine. That's the arc sine. And then in the expression, I need the square root of, let's try this again, square root of, and I need v squared in the top, so 42 squared, divided by, and for the denominator, I have a full expression, so I need to put it in parentheses, 2v squared, 2 times 42 squared, plus 64h, 64 times h, 6.6. I'm going to close the denominator, I'm going to close the parenthesis of the square root, and I'm going to close the parenthesis of the inverse sine. And the answer is approximately 41.93 degrees.